Yes. So in the continuation of the previous class, can you tell me this which category it will be coming out, whether it is a directed, undirected or weighted?
Undirected.
Undirected. If suppose I am going to remove an element called C, then what will happen? What we want to do in this list representation as well as the graph representation? If I am going to remove this C, what I want to do in the list representation as well as the graph representation?
We want to delete the links edge.
First, we want to delete the node, right?
Yes, sir.
First, we want
delete
to
that
delete the.
row and column.
So first, we want to delete this node, the node which will be carried out in the node variable. In the previous example we have done, all the node has been stored in a variable called nodes. So in that nodes, we want to delete that particular node first. So this is my first representation. And what is my second representation?
Delete row and column.
So I want to delete this C row as well as C column. So this is my representation. So likewise, we want to delete those things. While deleting those things, this linked list concept, this list will be deleted and this column also will be deleted and remaining will be there. If suppose you are going with 5 nodes, 5 vertices, and once you are deleting the node count will be -1. When you are inserting a node count will be +1. While you are deleting the node count will be -1. So that we want to implement in the program. So it means if you are giving the -1s over here, the matrix representation also will be changed. When you are going with 5 into 5 matrix and you are deleting one node, then after deleting that node, the node will be -1. So it will be coming of 4 into 4 matrix. So that way we want to get an output. For this, we are going to write a code for this. And in the previous class, we have written the code for adding a node, adding an edges, and printing the graph. So now we are going to write a code for delete node. So how many arguments I want to pass here for deleting a node? One argument I want to pass. So I am passing the argument called V. So first what we want to do now? In the delete process, first what we want to do?
That node is present or not.
Yes, first we want to check whether that particular node is present or not. If we not in nodes, then what will happen? I want to print a message that node is not present. If it is present, then what we want to do first step? If it is present, yes, the C has been present. So I have identified that the C has been present. So what we want to do first?
Delete that node.
We want to delete this particular node, right? Yes?
Yes, sir.
Yes. So I am using here the pop function I am using to pop up the node from the particular list. I am using the pop function with the node, whatever node I want to use that pop function over. What it means? Sorry, one more.
Index, sir.
Yes. Index value. I want to take the index values. For the pop function, it will be of deleting the list. You want to take an index value first. So first I want to delete this node. This is my concept. I want to delete this node. Here the nodes has been represented. We don't know where the node is exactly present in the list. For exactly present, the node want to be present in the list. We want to check the index value of the particular node. after finding out the index value, we want to remove that particular index value from the list. And after finding the index value, we want to remove all the functions that was present in the list, right? 2 and 2 we want to remove in the graph, right? Yes. First, we want to identify the node, and we want to identify the index value of that particular node. And after finding out the index value, we want, based upon the index value, we want to remove those index value in the matrix representation. Am I right?
Yes, sir.
Yes. So in the else part, I want to find out the index 1 is equal to nodes. That was the nodes, all the nodes that has been stored in the nodes list. In that, I want to represent the index of V, what the value that we are going to pass, that I want to find out the index for that particular value. And after finding out the value, what you want to do? Node underscore count is equal to node underscore count minus 1. So whether it will be running here. Here what we have done for adding the node, we have incremented the node by 1, right?
Yes, sir.
Yes, for deleting the node, we are decrementing the node by 1. In this, we have used here as a global variable that the node was outside the function. So we have used that global variable called node count. And here also we want to use that node count inside the function. So we are using this global of node count. Why? Because the node count has been declared in the main program, not inside the function. So we are making this as a global variable and we are using this inside the function. So here we are decremented the node. So what is the next step now? We have identified the, yes, we have identifying the index value of the node, and after identifying the index value, we want to remove that particular index value from the node. It means node dot remove function we are using, and we are removing that B. So it means this, if you are inserting C, it will check first. It will check whether C is available in the nodes or not. Yes, C is available, and then it will be going to the else part. And here the index value of C has been represented as 2. And after finding that, the node count will be decremented by 4. And after that, the index value of 2 will be removed. That means the C will be removed from the nodes. That is the thing. So first step what we have done, first we have removed this C from the nodes. That is the first step. And second, what we want to do,
Delete row and column.
delete row and column. So the graph representation, I have kept that graph representation in a variable called the graph, and I am popping that index value that we have gotten for that particular deletion node. So graph dot pop index 1. What is the index 1 now?
C.
2. C. So index value will be 2, and after that, for I in graph, I dot pop of index. So it means it has, we are represented, we are storing this index value from here. From this index value 2, it will be checking whether the index value 2 will be available for all the nodes. It will be checking the index value 2 was available for all the nodes. If it is available over there, that is index value, that index value will be popped. It will be first checking, it will be in the A, it will be checking over here, and it will check 0, 1, 2, the index value will be 0, 1, and 2. If the 2 index value has been came, then it will be popped, and again it will be checking for B, and it will be popped. And C, all the elements will be popped. So the basic, here also the index value will be 2. So all the elements will be popped. Likewise, it will be removing this line as well as this line. Clear? Clear? For this
Sir,
code, for this, yes.
sir, sir, for in graph that we want to delete, that function we are using for deleting in edges are, sir, edges are linked
For
in graph.
deleting the edges, yes. For deleting all the edges, that was represented by C.
Okay,
The C node want to be deleted first, so that all the edges that was connected by C, it will be deleted. And after that, the C column want to be deleted. It also, all the edges was connected by the C want to be deleted. Why? Because it was an undirected graph. For that undirected graph, you want to delete all the operation from here. So whatever the node has been connected for from all the sides, we want to delete those things. So you can see only four numbers will be there. It will be connected from A to C, C to A, C to D, and D to C. So four links will be there for C. So when you are seeing this, the four ones will be available. So all the four ones want to be removed from that particular graph. For that, we are checking whether the index value of the particular C as mentioned here. It means the index value 2 in the column want to be deleted, the index value 2 in the row also want to be deleted. So that's why that is mentioned there.
okay, sir.
So it was popping those elements that was present in the matrix. For that was mentioned there. So if after completion of this, so this is the program for deleting the node, and after completion of this, delete. What will be the output now?
So A not present.
So it will be showing that the A will not be present in the graph. So here you can see the display. So the node which I have given, that A is not present in the graph, that was mentioned here. If suppose I am giving this as E, you can see here the E row, the E no vertices has been deleted. After deletion of the vertices, the node will be like this, that is NINT. So here you can see this 3 into 3 matrix that was differentiated by 3 into 3 matrix, and the ELE row and column has been deleted. So each row and column has been deleted over here. So you can see the difference between these two output, right? Yes, yes. You can able to see the difference between the two output, right? After deletion of the nodes.
Yes, sir.
Yes, so that is the thing for deleting a node. So that is the lines for deleting the node. And next thing you want to delete an edge, right? So now coming to the deleting an edge concept, if I am deleting the edge between C and D, whether any changes will be happen in the node list.
No, sir.
No, where the changes will be
Matrix representation.
in the matrix
CD and
representation.
column.
Yes, in C and D. That means C and D. Here we want to mention this as 0, and D and C. Here we want to mention this as 0, right?
Yes, sir.
So what we want to do in the code?
Graph of list one list.
What we want to do in the code for changing the values in the graph, what we want to do in the code. We have done for the edge insertion method in the previous class.
Zero, sir. We want to give.
So the edge we will represent V1 and V2, right? So two arguments we are going to pass because we want to give the edges between the two nodes, that is C and D. So I am collecting two arguments. So if I am collecting C and D, then what we want to do now?
We want to give 0, sir, for relation.
Yes, how you want to give the 0?
Graph of V1, V2 equal to 0.
Graph of V1 and V2 is equal to 0. No? Can
So we are
anyone?
Index of V1 and V2.
Yes, we want to find out the index of the thing V1. The V1 is the node called C and V2 is the node called D. And we want to find out the index of V1 and V2, that is C and D. So it means C and D is the 2 and 3, that is the index value of 2 and 3. So it will be changing 2 and 3, the particular value will be changed as 0. And again we want to find out for V2 and V1. So V2 is 3 and V1 is V2 V2 is 3 and V1 is 2. So 3 comma 2, the index value will be changed of 0. So in this graphic representation, first we want to find out the index value in the list. And after finding the index value, we want to change the values as 0 as well as 1. If it is 0, if it is 1, we want to change that value as 0. If it is already the node is not present, then the value will be 0. So you're not able to change anything. The program will not be disturb the lines, disturb the matrix also. If it is already the edges was not available, then it won't disturb anything. So that's the thing we want to write the code. So first what we want to do now? If delete edge. How many arguments?
2.
Two arguments. So v1 comma v2. And first what we want to do?
Whether edge is present or not.
Yes, in the add edge concept, we have defined the two things. Whether v1 is in the node or v2 is in the node. First we want to find out whether all the things were inside the node. And after that, the else part will be executed. What we want to do in the else part first?
Finding index 1.
Index 1. So index 1 is equal to nodes dot index of v1. And index 2 is equal to nodes dot index dot v2. And so we have find out the index value. Then what we want to do in a graph representation? We want to change that particular value into 0, right?
Yes, sir.
Yes. So what we want to do? We are a pitch of index 1 of index 2 index 1 index 2 is equal to 0. Index 2 of index 1 is equal to 0. This is right?
Yes, sir.
Yes. So now the function has been completed. So it means that it won't disturb any nodes here. We are not going to do anything apart from this node, and we are going to delete the edges in a matrix representation. That we are going to delete the edges in a matrix representation based upon the index value that the argument has been passed. Based upon the index value, taking the index value of both and finding out the exact location of those index value, and after finding out the exact location, we are just assigning the value is 0. So if I am calling this function, H. What was the output now? The output is right. The output is right.
Yes, sir. P is not present.
Yes, E is not present. Why? Because we have deleted the node E in the previous itself in a deleting node concept, and after that we are deleting the edge for that particular E. So it will be deleting this. This E will be showing the error that E node is not present. So if suppose I am giving this E n comma I, you can see here this. So this is my first node. First thing I have inserted the node and the edge for the particular four nodes, and after that I am going to delete one node. It means it was deleted the node and it was represented as 3 into 3 matrix. And after finding out this, we have done doing this edge operation, deleting the edge operation. In that edge operation I am going to delete this n and I edge I have deleted. So here see this n and I edges has been removed here. These two edges has been removed and the final output has been displayed. Right? So if suppose I am giving this, again I am giving this n and I, any error will be coming here. Again, I have already removed the edge called n comma I, and again I am deleting an edge in n and I. Any error will be coming here.
Yes, it's already deleted. Link.
No,
So no change.
no change. So it won't come. It won't. It will display the particular result what we have done in the previous part. It won't disturb the lines of code. It will be displaying the result. So same thing, same element has been displayed in the result. It won't give any changes because I already the I and N and I edges was not present in that particular matrix. So it won't change anything in the code. So that is the thing. So this is the delete operation for the node and delete operation of the edge in a matrix representation. Right?
Yes, sir.
Yes. Any queries in this? Any queries? What we want to do for a directed graph in this for deleting the operation? So this is an undirected graph. So anything want to be changed in a directed graph? For deleting a node, whether we want to change anything in the directed graph.
No, sir.
No. Anything you want to change in the edge for directed graph?
Yes, sir.
What do you want to
Yes.
do?
In else, remove that second line, sir.
Yes, we want to remove that second line. If it is not removed also, the automatically the value will be 0 for that particular line. So there is no big changes between the deleting graph and deleting node in a directed graph. If suppose you are going for a weighted graph
We want to pass another argument.
called,
Cost.
Or weight or cost anything.
before deleting the node itself, you know the cost for that particular node. I have not seen that particular lines of code. I am asking you. You just take that as your assignment. This lines of code want to be written. Assignment number 4.1. Note it down. You want to write the lines of code for the add node operation, add edge operation, delete node, delete edge, and graph operation only with the weighted graph, not with the directed and undirected graph. You can take either directed weighted graph or undirected weighted graph. So this is your assignment number 4.1, right?
Okay, sir.
Yes, we just I am not get into those lines of code for deleting a graph in the weighted method. You just Google it and search that how you want to delete those weighted graph, weighted node and weighted edges. So so make that as assignment as 4.1. Yes. And what is this representation of?
List represent.
List representation. So here same thing we want to do. In the list we want to delete the rows and radius is this. So here same thing I want to do. I want to delete the node called C. Then what will happen? First step in the list representation.
C will be removed.
C, which C will be removed? What is the meaning of C in a graph, in a dictionary?
Keyword.
Keyword. Yes,
C.
first this C will be removed. It means that it will be removing all the elements. And after that, what we want to do?
Again, we'll search in list anywhere C is present.
We want to check all the list, right?
Yes,
Yes,
sir.
sir.
Yes. Yes. And after that, we want to check one by one. We want to check one by one element, and we want to find whether the C is applicable in that particular key element. First, we want to check with the A element, and after that, we want to check the nested list, and after that, we want to check whether the C is present or not, right? For A, B, D, and E. Am I right?
Yes, sir.
Yes. So this is a simple technique. Only one representation will be there. We are going to use the for loop and if condition in this. First, we want to remove, we want to pop that particular element. That means particular delete, we want whatever the element we want to delete. First, we want to pop the element from the dictionary, out of the dictionary. This is the first step. And after that, based upon the for loop, we are going to represent all the elements in the dictionary. And after that, we are checking the condition, that is if loop, for checking the condition for each and individual element that was present in the list or not. So we are going to access with three conditions. One is for loop. First, we want to pop the element outside of the graph, whatever the element we want to remove. And after popping, we want to go with the for statement for checking A, B, D, and E. And after the for statement, we want to use the if statement, whether we want to use the if statement to check whether the deleted node has been present in the particular nested list or not. So for that, we are using three conditions over here. So remember those conditions. So delete. So how many arguments?
One.
One. So first what we want to do now?
Whether node is present.
Yes, for all the statement when you are inserting or deleting, we are not supposed to check whether that particular node is present in this list or not. And if it is not present, then what we want to do?
Index value. Check.
There is no index value. So I have not told any index value because it is based upon the index value, we can delete the edge. Based upon there is no index, it was not a nested list representation, and also this is a dictionary representation. We want to mention that as a keyword, key value.
Yes, sir.
So we are going to access directly the graph by using this graph.pop method, and we are removing the first. So this is the first step I have told you that we want to remove the element from the dictionary, right? Yes. So what will happen now? So if suppose I am going to delete this C, I am going to taking this as C. It will check whether C is available in a graph. Yes, C is available. It will goes to the else part, and it will pop the element called C. So what it means in the graph, what it means in the diagram. So first it will check whether C is available in a graph. Yes, C is available, and after that it will pop this, right.
Yes,
If you are removing this, what will happen? The nested list also it will be popping out, right? Yes. Am I right? So this A and D also will be popped out from the C. And after that, what I have told, we want to go with each and individual element in a graph by using the for loop. For I in graph means it will take the first element in a graph. That means A. Likewise, it will be taking this element from the list from the graph. List 1 is equal to graph of I. So it will take the first element A and it will represent the list that was present in a graph. In the ith element, what are the list that was present that will be directly accessed into that. And if P in list 1, then list 1 dot remove V. So for statement, it will directly go to the for statement. It will access the keyword, and after that, the list will be represented in the keyboard. So first we are accessing the eighth element, and it will represent the nested list. And after that, it will take the V. V in the sense we are getting C. So first is the C node will be compared with D. So it was not present, and again it will be compared with C. So it is present. If it is present, then what will happen? It will be removing the C from the A, right? And for this, again the for loop will be coming here after completion. After checking all the elements, again the for loop will be coming here to the B, and it will be checking individually. So in this B, there is no C node is available, so it won't do anything in the B operation. And again it will come to D. Why? Because we have already removed that C from the dictionary, so it will be coming to D, and it will check A, B, and here the C is being represented, and it will be removed from this. And after that, it will be D. Again, it will come to E, and it will check remaining two nodes in the E. So there is no changes. So it means that we are going to delete a node in a key called A, and we are going to delete node in a key called D. So after completion of this, after deleting this edges also will be deleted automatically, and this edges also will be deleted automatically. Clear? Yes? Any doubts in this? Am I audible?
Yes, sir. Audible, sir.
Yes. Any doubts in this?
No, sir.
No. So the only thing, first we are popping that particular element in a list, and after popping, taking all the element in a graph, and we are accessing the graph list over here with the keyword. What the index value, that is 0, it will be represented, or 0 1 2, or it will be taken A, B, and C, whatever it may be, that will be represented, and it will be going into the nested list. And after going into the nested list, it will check whether that particular node has been present in the nested list or not. If it is present, the node will be removed from the nested list. So after completion of this, so I have added a node called NAET, and I have added the edge for NI and NE and NT, and I am printing this, and I want to delete this node called E. So after deleting the node, what will happen now? So I'm taking 4 nodes, N, I, N, and so what are the edges I have given? N to I, N to E, and N to T. So 3 edges has been given, and after that I am deleting the node called E. Then what will be the representation? List representation. N, which will be consist of only one element called I, right?
T also.
T also. Yes. N and T, and I will be consist of only one representation, that is N, and T will be consist of only one representation called N. So this will be my output after completing removing this things. So this is a undirected graph, undirected non-weighted graph. Whether this is right? No.
No, sir.
Sir,
Yes.
there if
What
we
was?
enlist in the,
Yes.
that line is not there, sir. We had to use another for loop.
Where here?
After for I in graph, another for we have to use, sir. For J in list 1.
No, that is for a weighted graph. This is an unweighted graph. So you are telling for that weighted graph, another for loop will be coming to check the particular weight for that particular node. So that is a weighted graph.
Okay, sir.
What was the mistake I have done?
Sir, V2, V1 with this and dot V2.
Yes, so this is for adding a node and adding a edges for this. So that we have discussed in a previous class for the weighted graph. So if I am deleting this node called n, then I want to delete that node, right? The n was not deleted. It was mentioned already. N is already present. I'm going to add the node. I'm going to delete the node. Delete the node. What was the mistake I have been done? Declare a function of delete node, and after adding the edges, I'm printing the graph. And after that, I'm calling the delete node function. The delete node, I'm giving the print graph. So it was taking to the add function, right? So can anyone do this code and get an output? Try to get an output. So the code was correct, but it was not. It was directly going to the add function. Can anyone tell me what was wrong in this? Initializing the graph and getting the nodes and connecting the edges, printing the graph, and I'm using the delete operation. In this delete operation, I'm giving the nodes over here called this already present. So here only I have given this value. Sorry, B not sir. So here I have given if B in graph, right? So the first step. Yes.
Sir.
Yes. So here I have given B in a graph. So you want to check whether the E is not present in the graph. That thing you want to check there. And if it is there, and you can see here the E node has been deleted. The E node has been deleted, and the N was connected here, and already here E was in the nested list of N. So that particular E also deleted in the nested list of N. Are you getting this? An output. Yes.
Yes, sir.
Yes. So same thing. Make this as a assignment 4.2. and take a graph representation for the list, for finding the list. You want to add the add node function, add edge and delete function for the cost graph that can be a weighted or unweighted. That may be depends. So you want to do the cost graph calculation for the list also. Right? That is an assignment number 4 point. Clear? So same code will be there, only one statement will be coming apart from this. So find out the statement in Google, and after that you write the code and execute the code. No need to write those codes. You just execute the code, take the snapshot and make that PDF and keep ready. No need to write the code. Right? Or else you want to write the code.
No, sir.
Don't need to
No.
write, sir.
Who told
Okay.
first to know? Who told first to know? Have received first to know from one of them. Who is that? Who told me the first to know? If you are not opening the mouth, I will give you all the to write this. Who, who told me the first to know? Then you can write that, no problem. You can write in a A4 sheet, and after that you can type, and after that you can take a note. If you are not opening the mouth, you can write that. 4.1 and 4.2, you want to write and you want to do the system work also. Fine. So if you are having any doubts, you can ask me, or else you can give your attendance and you can give.